In this video, we're going to take a look at the idea of a relation and a function and some of the more elementary concepts related to functions and relations. So let's start by defining what a relation is and what a function is. A relation is essentially going to be a collection of ordered pairs. And it doesn't necessarily have to have like any sort of rules to it. So we could have one specific element in one set connecting to every single element in another set, all right, or associated with that. But a function is a specific type of relation. So a function is basically going to say that for every one specific input, or in other words, every element in one set is going to correspond to exactly one element in the second set. So basically, if we think of a function as a machine and we have like these inputs, if we have one input, what's going to happen is for a function, we're going to have one specific output for that. Now we know that in every machine, there's only certain inputs and certain outputs. So the domain is going to be all the set of inputs. The range is going to be all the set of outputs. All right, so anything that can go into a machine and give you an output is going to be the domain, and all the possible outputs are going to be the range for that function. If a relation has two or more possible outputs, then it's not going to be a function. So let's say, for instance, I throw in a 3 into my function machine, and it spits out like a 4 one time, and then another time it spits out a 6. That means it's not a function. It's more of a relation than a function. All right, so that's probably the way to think of what a function is going to be. It's just going to be an input versus an output. All right, one input to one output. So if we have this thing called a vertical line test, if we have the graph of a function, and if we can draw a single line vertically, and that single line, anywhere we draw it, touches exactly one point on the graph, then we can say that the relation is going to be a specific function. If it touches more than one point, then it's going to be a relation, but not a function. And so we have a diagram here that shows you a basic overview as to how a function works. So if we throw the number 5 into our function machine and we multiply it by 2, we get out 10. Every time we multiply 5 by 2, we get 10. We're not going to get any other sorts of numbers as long as we do that correctly. The same thing with squaring a number. If we throw 5 into our function machine and we square it, every time we get 25 out of it. However, an example of a relation, but not a function, is let's say we throw the number 5 into our function machine and it just spits out a bigger number. And it could say it spits out 6, or it spits out 7, or it spits out 23, or it spits out 29. There's so many different outputs that it's not a function. The same thing with the idea of a square root. Like for instance, if we say 4 square, well, that's going to be 16. But also negative 4 square is 16. All right. And if we take the square root, that's the inverse function. And so when we take the square root of our positive values, then we're not necessarily generating a function because there's two possible outputs for that. All right, so we want to keep these things in mind as to what's a function and what's not a function. If we were to draw a diagram, we have these numbers, -3 all the way to 1, and every single one of them points to a unique value. All right, and so if that's true, then we have a function. And we can always draw a diagram for that. But not a function is if we have a singular input and it puts two numbers out of it. Okay, so if we have like the function machine and we have 1 and we throw that into our function machine, and for some reason out of our function machine, we're going to get the numbers 0 and 15, then it's not going to be a function. All right, so these are the ways to think about what a function is and what a function is not with respect to relations. So let's take a look at some easy examples as to how to start working with these sorts of functions. So we have these relations, okay? So we have two sets of relations here, and we want to just determine if the relation is a function. And if it is no matter what, we're going to find the domain and the range of each of those. And one of the easiest ways to do this is to just draw a diagram of the domain and range. All right, so this is our domain. And that's just going to be the numbers 1, 2, and 3. Those are the x coordinates of our ordered pairs. So we have 1, 2, and 3, just like the diagram above. And for our range for this, well, we know that 1 is going to point to 2. We know that 2 is going to point to 3. and that 3 is also going to point to 3. And that's okay. We can have two different inputs point to the same output. Okay, so this is a function. So it is a function. The domain of this function is going to be the set 1, 2, 3, and the range of this function is going to be the values 2, 3. Now, an example of a relation that's not a function, and this one's pretty easy to see that it's not a function. We can see it automatically that we have those couple 2's that are going to point to the same value. So we have a domain, which is going to be 2, 4, and 6. And then for our range for this, we have 3, 4, 5, and 7. And notice that the 2 points to both 3 and a 4. So right away, that is not a function. And we don't have to do anything else with it except for finding the domain and range. All right. The domain of this function is going to be the set of numbers 2, 4, 6. And the range is going to be the numbers 3, 4, 5, and 7. All right. So that's probably the easiest way to determine if a relation is a function if you're given the ordered pairs. If you're given an equation and you want to determine if that equation of x and y is going to say that y is a function of x, the easiest way to determine this is to solve this for y and see if every number that you plug in is going to give you that one-to-one sort of relationship. So one input gives you one output. So if we were to solve this for y, the first thing we would do is subtract 6x from both sides. And so if we do that, that's going to cancel out and we get 3y equals 12 minus 6x. And the last thing we would do to solve this is divide everything by 3, right? Just like we do with our linear algebra. And so this would be y equals 4 minus 2x. And this shows us that for every single one input for x, so no matter what number we plug in, we're going to multiply it by 2, and then we're also going to subtract that number from 4. So we would say, yes, this is a function, because every time we plug something in, we're going to get a different number. And if you don't believe me, go ahead and plug in a whole bunch of numbers. Now for letter B, this one's a little bit sneakier because we have this y squared. All right, so we're going to do the exact same thing we did before. We're going to subtract 6x, and we're going to get that 3y squared is going to be equal to 12 minus 6x. We're going to divide by 3, just like we did in the previous. And that's going to give us that y squared is going to be equal to 4 minus 2x. And then now what we're going to do is we're going to take the square root. And you might remember that if you take the square root of a number, or if you solve a quadratic with a square root, you have to put a plus minus in there. And that's sort of like what we did up here, if you recall, with this square root of a number, right? So whenever you take the square root of a number, if you take 16 and you take the square root of it, it could either be positive or negative 4. And most of the time we just take the positive value, but we can't forget that there is a negative value there. All right, so in this case, going back down to here, all right, this tells us that if for some reason I were to plug in the same number, all right, so let's say I plugged in 0 for x. So y would be equal to plus or minus square root of 4 minus 2 times 0, which means that y is going to be equal to plus minus root 4, which is plus or minus 2. And that's 2 outputs. So what we would say is that this is not a function of x. Right? So again, if you get more than one value out, that means that it's not going to be a function. Right? For letter C, to solve this one for y, we just subtract the absolute value of x. And so we get y is equal to 1 minus the absolute value of x. Now think about this. If you were to plug in some numbers for x, you might get the same output, but that's okay. All right? For every number you plug in, you're only going to get one singular output for this. All right. And if you don't believe me, go ahead and plug in 0, 1, 2, 3, negative 1. And if I plug in 0 for x, that's going to give me a 1. If I plug in 1 for x, that's going to be a 0. If I plug in 2 for x, that means I'm going to get 1 minus 2, which is going to be negative 1, 1 minus 3, negative 2, 1 minus the absolute value of negative 1, which is going to be 1 minus 1, which is 0. All right. And so what we see is that for every input, it's drawing an arrow to exactly one output. So one of the tricks you can do with this is solve it for y, or solve the relation for y, and then maybe plug in a few numbers and see if you get one input for one output. So this one is, yes, it is a function. Right. And then finally, for letter D, the trick to this one, to solving it for x, is that we have a couple y's here, and of course we can't combine like terms with that. So one of the tricks we might do is factor the y out. Right? And remember, this is basically reversal of the distributive property. So we're just saying y, 3 plus x equals 6, and then we can divide both sides by 3 plus x. Right? And so y is equal to 6 over 3 plus x. And again, if you want to go ahead and start plugging a few numbers in, like let's say we plugged in 0 for x, and then we plugged in something like negative 1 and negative 2, and I'm just arbitrarily choosing a few values. If I plug in 0 for x, 6 divided by 3 plus 0 is 6 divided by 3, which is 2. 6 divided by 3 minus 1, 6 divided by 2 is going to give us 3. And then 6 divided by 1 is going to be 6. And notice that each time for every one x we plug in, we get one output. So yes, this is going to be a function. All right, so again, we want to make sure that when we're doing this, the only time that we're going to not have a function is if we get two outputs for one input, just like we did here, where we had like that plus minus. Right? Now, one other thing that we discussed earlier for how to determine if a function or a relation is going to be a function is the vertical line test. And so, for instance, if I was to draw a vertical line through letter A, well, that's good, but then we get to here, and it intersects at two spots. So this is not a function for letter A. But if I were to draw a vertical line through the 3 coordinates, okay, this one is a function. Right? If we go over here, draw a line, draw a line, draw a line, draw a vertical, and yes, every place we draw a vertical line, that it only intersects in one spot. So this is a function of x. Over here, same thing. All right, and if you don't believe me, you can certainly zoom in a little bit, and we can see that no matter where we draw a line, it intersects at exactly one spot. All right, even over here, that's fine. So yes, this relation is a function. Now over here, if I draw a vertical line through the vertical line, it intersects at every spot. So that's not, and then over here, if I draw a vertical line, it passes through 2 points. So no, that is not a function. All right, so that's the vertical line test if you have the graph of a relation to determine if that relation is a function or not. All right, so hopefully this helps you to understand a little bit about the basics of functions, or if you already knew this, to kind of revisit those sorts of things. And then in the next video, what we're going to do is we're going to start taking a little bit more of a gander at the intricacies of the graphs of functions.